Hello everyone, this is Ayushi Gupta. Welcome to the 20th episode of Microsoft Art of Code brought to you by Millionlights. Millionlights is a TV channel dedicated to improving the skills of people in their employability. Now let me tell you a little more about the Microsoft Art of Code. Microsoft Art of Code is a series of lectures, courses and talks by experts who are going to be discussing the latest Microsoft technologies and topics related to programming and industry forecasts that are all focused on employability. Today, we are going to learn the C# fundamentals. This is a beginner's course for people pursuing computer science. These episodes have everything you need to upgrade your skills. These courses are not only beneficial for students, but also for working people. As you know, today we are going to learn the C# fundamentals. This content has been created by our partner Microsoft. We have Bob Tabor from Microsoft with us, who will help you learn the fundamentals of C#. But before we start, you need to have a computer system with a 64-bit processor or a 32-bit processor, a Windows notepad, and any web browser such as Internet Explorer. If you want to learn a different programming language, C# is a great place to start. Tune in to learn the basics of C# language and learn how to apply them in your programming endeavors like video games, mobile environments, and client apps. Learn C#, get the tools, see how to write code, debug features, explore customizations, and much more. In this course, C# for beginners, let's have a look at what we are going to be learning. The topics that we will cover in this episode include operators, expressions, and statements, in which we will learn how to create a properly formed C# statement made up of expressions that include both operators as well as operands. Hear about compilation errors that occur when the rules of syntax are not followed in C#. 4 iteration statements, in which we will look at several different types of iteration statements. How to utilize the code snippets to help remind you of the syntax for this complex statement, and debugging in action. Understanding arrays, in which we will learn about arrays and see how to declare as well as utilize arrays. Watch demos on a couple of powerful built-in methods that give arrays additional features. So let's get started.
Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to spend a bit more time talking about some smaller syntax elements of the C# language that you need to master to understand how a properly formed line of code is constructed in C#. And in one of the previous lessons, almost like the first lesson, I said something to the effect that just like you use a period or question mark or exclamation mark at the end of a sentence in English to complete a thought, you also use a semicolon at the end of a line of code in C# to denote a complete thought. And kind of to extend that analogy a little bit, I may have briefly referred to C# syntax as having nouns and verbs. So I want to elaborate on these sorts of things and clarify what I mean by that in this lesson. So I'm going to talk about the basic building blocks and I guess you could say parsing the parts of speech in C#. So let's start off at the beginning. Statements are what you call complete thoughts in C#, typically one line of code. A statement is made up of one or more expressions. And expressions are made up of one or more operators and operands. So we've seen a number of statements and expressions and operators and operands already, whether you realized it or not. So as we're taking a look at some of the previous work that we've done, here I've got the variables project from a previous lesson opened up. And so, for example, you can see that essentially each line of code is a statement. Each of them are made up of one or more expressions. So here, for example, is an example expression. This happens to be a variable declaration statement made up of a operator, which in this case is a keyword int for the data type integer, and then an operand, in this case a variable name. We also use another operator, the semicolon, for the end of the line of code. Another example would be here where we have an assignment where we're actually calling a method. So here is an operand. It is the name of a class, and we're using the open close parentheses. Remember, these are operators. This is the method invocation operator. Then we're using another operator here, the assignment operator, to assign this expression, the value of this expression, to another operand, the name of a variable that we created. All right. So if we were to look through the code, we could continue to kind of parse out and understand what makes up operands, operators, expressions, and then entire code statements. Now, operands are similar to nouns. They are things like objects and classes and variables and even literal values. These are the subject, I guess you could say, of your statement of code. And they're pretty easy to remember because typically you give them names, you define the values yourself, and so on. Now, operators are similar to verbs. They are things like the addition operator or the string concatenation operator. These are things that act on the operands in order to perform some action. And typically you're going to use the built-in operators, although you could create your own operators, kind of a little bit of an advanced topic, but there are actually quite a few built-in operators, and you're going to need to memorize many of them. That's how you come to express yourself in C#. Now, fortunately, as you start out, you probably only need to know a handful to be productive. And so what I want to do in this lesson is to focus on a few that I think you're going to use probably 90% of the time as you begin learning, and you can obviously add to that list as we continue. So I'm going to actually present these in a rapid-fire fashion. I've created a very nonsensical application. You can open this up, download it from wherever you're currently watching this video or wherever you originally downloaded it from. I called this project Operators Expression Statements, and the application itself does absolutely nothing meaningful at all, okay? And so all it really does is kind of show you some examples of the various operators and expressions that you'll come across whenever you're working in C#. All right, so at the very outset here, you can see that I have a variable declaration. We talked about this already. I did something a little bit different this time, where I've declared several variables all up front as integers. So X, Y, A, and B are all defined as integers. Just wanted to show you something a little bit different there. By separating them with commas, it's an easy way to just to declare several variables of the same type all on one line of code. Now, I typically don't recommend this, but you might see this around in use in books and on the internet. All right, so next up, assignment operator. We've already seen the equal sign at work in that capacity. Note here in line number 22 and following that there are actually many different mathematical operators. We're only looking at the most basic ones, but there are also some advanced ones as well. But here we have addition and subtraction, multiplication and division. And as I demonstrate here, you can use parentheses to actually change the order of operations. So these are not, in this particular situation, the parenthesis is not a method invocation operator. It's actually how you would typically use it in an algebraic or mathematical sense. You would use it in order to specify the order of operations. So perform this expression first, then this expression, and then take the results of those two and multiply them together in that third expression, and then assign them to the value of x. Okay. And then there are there are operators that are used to evaluate. We've already talked about the equality operator, where we're using two equal signs next to each other to make sure that these two items are in fact equal. Here again, we're using parentheses in yet a different capacity to define the boundaries of our expression that will either equate to true or false. So x equals y is either true or false. We can use greater than, we can use the less than operator, we can use greater than or equal to, less than or equal to. All of these, again, should produce a true or false result. There are also two conditional operators that can be used to expand or enhance an evaluation. And they can be combined together multiple times, as I say here in the comments. So I could ensure that both x is greater than y is true and a is greater than b is true by using the logical AND operator. There's also an OR operator to say either x has to be greater than y or a has to be greater than b in order for this outermost expression to be true. All right, so here's the logical OR, two pipe characters next to each other. All right. So, and then I guess we've already talked about that inline conditional operator where we have some item that's being evaluated, and then if it's true, then we'll take the first value, and if it's false, then we'll take the second value. And in this case, we're assigning either car or boat into this message variable's value. And then also wanted to talk about member access and method invocation. We're going to talk about object-oriented programming quite a bit later on in this series of lessons, but we've already said how the console was a class, and classes are containers, for a lack of a more robust definition, for methods. And the way that you access a member method of a class or an object is by using the dot or the period. That is the member accessor operator. Furthermore, we talked about the method invocation operator. Here we are invoking a method called WriteLine by using the opening and closing parentheses. And in this particular case, we're passing in an input parameter. Again, we want to hold off and talk about input parameters and methods a little bit later. But as you can see, here's a number of different operators, and these are just what I would call a very baseline set. You need to memorize these so that you can express the most basic of C# commands and understand exactly what it is that you're trying to do. It's not an exhaustive list by any stretch of the imagination, but you will probably need these about 90-95% of the time. And then you can expand your vocabulary of other operators and keywords over time. So in each of these cases that we just looked at, an expression is made up of a combination of operands, which are things like the literal strings and variables and objects like the console class itself, and operators. So things like the addition operator, string concatenation operator, equality, assignment operators, and so on. And you use expressions then to form complete thoughts, statements in C#, which are how the actions or the instructions of an application are expressed to the compiler and ultimately to the .NET runtime, which executes your application. All right. So why am I telling you all of this? Why go through this little English lesson, you know, parsing out the different parts of speech if you've ever had to take an English class? Well, it will help you to understand why this is not a valid statement in C#. You can't just type x plus y and then give it a end-of-line character and expect it to do anything. The C# compiler will look at that and say, what are you trying to accomplish here? Have you lost your mind? What do you want me to do with all this? So fortunately, in situations like these, as you can see, Visual Studio can catch these sorts of syntactical mistakes even before you attempt to run the application. And, you know, if we were to hover our mouse cursor over the visual the visual guidance here, the red squiggly line, you can see that the fundamental problem with this line of code is that only assignment, call, increment, decrement, and new object expressions can be used as a statement. So what's the problem here? Well, this is not a properly formed statement. We're not assigning, calling, incrementing, decrementing, or creating new object expressions. We're not formulating a complete thought, a good sentence. I mean, I could create an English sentence like this: the red ball, period. And you would say, the red ball does what? Who has the red ball? Okay. We can understand that just because you use words doesn't mean you're creating a complete thought or expression inside of the English language. Same thing is true with C#. All right, that's all I'm trying to say here. So for beginners, understand that there's a proper syntax, just like there's a proper grammar in the English language. Understanding this is really a big step towards solving your own problems whenever you're phrasing C# instructions that the C# compiler will understand and accept and ultimately compile into code that will be run by the .NET Framework. So here, let's recap what we talked about in this lesson. First of all, statements are complete instructions in C#. They consist of expressions. And a statement is like a sentence in the English language, and expressions are composed of things like nouns and verbs. In other words, operators and operands. The operands are things like nouns. They're the subject or what we want to do something with. And then there are the operators, which are more like the verbs. These will act on the nouns to perform some action. We said that operands are like variables and classes, literal strings. These are things that we get to name ourselves. They give the meaning to our application, whereas operators are, for the most part, built into the language, and we have to memorize them. And so to start off, you might use something like what I've given you here in the form of a project for a cheat sheet. But I think you might just be able to walk your way through and rationalize your way through now that you understand that there's a proper way to format a line of code. You might say, okay, what do I need to do here? And you might be able to reason your way through the operands and the operators. I'm going to need a variable to contain some values. And so once I have created that variable in memory, now I'm going to need to assign it to something. Now, how am I going to get to that something? I'm going to need to take another variable and this literal value, and I'm going to need to add them together with an operator. And hopefully you get the idea there, okay? Okay, so I hope that this was a useful exercise. I think it's useful for beginners to understand that there are syntax rules, and they're not so unlike what you're already familiar with. Maybe they look a little bit different than your typical English sentence, but they still have to make sense, and they have to perform an action, they have to do something. And so when you see errors, sometimes it's because you type something incorrectly, and then sometimes it's you may not be using the right forms of speech, in a sense, in order to express that complete thought in C#. Okay, so let's pick it up in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to focus on iteration statements, a specific iteration statement called the for iteration statement. Sometimes you're going to need to loop or iterate through a sequence of things to find something that you're looking for, to find a successful match. And actually, you're going to do this sort of data manipulation more than you realize. So you'll have to trust me that this is a very important tool in your toolbox that you're building. So as you can see, I've already taken the liberty of creating our project. I called it for iteration. Pause the video, go through the steps that you already know how to perform to create a new project, new console window project, and catch up with me. I'm going to begin to add some code here on line 13 in just a moment. Now, the syntax that we're going to write here in just a moment is possibly the most cryptic of anything that you've seen yet. And I'm going to be completely honest, Sometimes I get things a little bit mixed up myself, but don't worry. After we've struggled through it once or twice, I'm going to share the little secret that I use to get it perfect the first time, every time. All right. So having warned you about the complexity of the syntax, I'm still betting that you could figure it out and read it even before we actually attempt to run the application, even before I take the time to explain what each little bit of the application is doing. So let me write it out here, and then we'll try that. Okay, very simple, at least very compact section of code here. Actually, you need one more line of code, right? Console.readline. There we go. Now we're ready for action. Okay, so what do you think that this code does? Okay, got a theory in mind? Well, let's go ahead and run the application and see if your theory is true. All right, you can see that we have a list of numbers from 0 to 9, and then we can hit enter to continue on. So we're using C# to execute this little block of code right here until a certain condition is true, at which point we will stop executing that line of code and continue on to line number 17. So this for statement says that we should begin by declaring a variable. We're going to call it I. We could call it anything we want to. And we're going to initialize its value to 0. Now, as long as I is less than 10, we're going to continue to execute the code below it in our code block defined by our curly braces. Each time that we iterate through, we'll increment the value of I by 1. So this little bit right here is probably the part that you probably wouldn't completely understand unless I explain it to you. Remember how we use the plus equal sign in order to automatically take the value of message and add something to the end of it and then assign it back to the value of message? Remember that a couple lessons ago? We're essentially doing that here. This is the increment operator. So we're going to increment the value of I by 1. All right, so again, we're going to initialize and declare a variable and initialize the value. Then as long as this middle part is true, we'll execute the code below. And once we finish executing, then we will increment the value of I and then do that evaluation one more time. If it's still true, then we'll execute this code again. We'll increment I. If this is still true, we'll increment it again, and so on. All right, so that's how it works. Yes, this is cryptic syntax, but if you can just separate the three parts in your mind by remembering that there's semicolons that separate them, that can help. You know you're going to need to start off with some counter of some sort. You're going to need a condition, and then you're going to need an incrementer at the end. Okay. And again, I'll show you a way to remember this so you never forget it. But before we do that, let me comment out this line of code and give you a variation on this idea. This will be fun. So here we go. So you can see that I simply added inside of our code block for the for iteration statement another if statement with its own code block inside of it. And here we're checking the current value of I. And once we find something we're looking for where I is equal to 7, then what? We'll perform this code. What does this code do? Well, this part's obvious, but this break statement may not be so obvious. You use the break to bust out of or break out of the for iteration. So we're going to make it to the value where I is 7, and then we're going to hit the break statement, and then we'll continue on to line number 23. Let's see it in action. It's not going to look all that exciting, but I got an idea. All right, it found 7 and it pretty much finished, right? I have an idea. Why don't we watch this execute line by line? And to do that, we'll use the debugging tools inside of Visual Studio, which we have not even talked about up to this point, and yet is probably one of the most important features of using Visual Studio as opposed to just using a text editor and a command line compiler. To make this work, what I'm going to do is actually set a breakpoint here on this line of code. Now, how did I do that? I just went to this leftmost column and I clicked in the column, in that gray column, and it created a little red dot, and off to the right hand side you see that that whole line of code is outlined in red. Now there are, truth be told, a number of different ways to set a breakpoint. Probably the easiest way to do it is what I just showed you, but there's also keyboard shortcuts and there's menu options as well. So for example, with my blinking cursor on line number 16, I'll go to the debug window and I'll select toggle breakpoint. If we look over to the right hand side, you can also see that the F9 key will accomplish the same thing. Great. All right, so now let's go ahead and run the application and see what happens. All right, so immediately the application pops up, but before anything can be printed out to the console window, notice that we have paused the execution of our code, and we're paused right here on this breakpoint. Now at this point, what I can do is I can do a lot of cool things. First of all, I can see what my local variables values are currently. I can also change the value of those variables. I can monitor those values. I can change which line of code will get executed next, and a bunch of other things. Now this is not a series on debugging. I could easily spend an hour showing you a lot of cool little features. However, what I do want to do is call your attention to this little window at the bottom. Currently right now, we're in what's called debug time. And with the application execution pause on this line of code, the next line of code that's going to execute is that line right there that's highlighted in yellow. I can look at these little windows like this locals window, for example. And you can see that the locals window will contain any variables that are currently in scope at the moment. So obviously args is something that we haven't talked about yet. Let's ignore that one. But what I want to focus on is the value of I. Currently its value is 0. How do I know that? Because I'm looking here in the value column. I can also see what the data type of I is. It's an integer. All right. If I were to hover my mouse cursor over I, you can see I'd be able to see it there as well. And if I were to go and pin down that value, I'd be able to monitor it as well in this little helper window. In fact, I can kind of drag it around here. Now watch what happens. Let me readjust some things here. I'm going to step through this line of code. Now there's a couple of different ways I can step through the code. I'm going to recommend that we only talk about step over for right now. When we learn about methods, we can step into and step out of, but for right now, this middle button right here, the step over or the F10 key on your keyboard, is what we want. So I'm going to click it once, and notice that we jumped from line number 16 to line number 22. Why was that? Well, the reason was because I was not equal to 7, so we didn't execute the code inside of the code blocks underneath the if statement, and we jumped to the end of the for code block. Now let's continue just to step through this. You're going to see that we'll increment I by 1. Now when we do that, notice what happened. The value of I changed from 0 to 1, and that change is indicated by a change in color. Whenever you see the color red, that means something changed in the previous line execution. The value of that variable changed from some other value now to the value of 1. We can also see this in this little mini window right here as well, how it is now turned to the color red. Now that we've incremented, we're going to do the next check to see, is I still less than 10? And here we're going to step one more time into our program. Here we're going to step and in the line 14, which opens up our code block, and we'll do another assessment. Is I currently the value of 1 equal to 7? No. So we'll jump out of that if block and continue on. and we can just continue through this exercise until we reach where I is equal to 7. Now, truth be told, I don't have to keep hitting the step over button. I can just use this continue button, and this will just keep bringing me right back to the breakpoint. This basically says continue running until you hit another breakpoint. And so here at this point now, I see that my I is equal to 7, and that's what I'm checking for. So things should get interesting right now. I'm going to go back to start stepping line by line through my code, and here's where I hit the console.write line, and if I look now on screen, it actually did write that to the console window. And now I'm going to step through the next line of code, and notice that it jumped out from the break statement outside to line number 23, outside of the for statement, to the console.read line. We can hit continue from that point on. Our application is still running until we hit the enter key on the keyboard, and then we've exited out. All right, very cool. Now, you may have found it laborious to step through a number of times or even hit the continue button a number of times until we found just the right condition. So what we can do is make this breakpoint into a conditional breakpoint. So to do that, I'm going to hover over the little red stop sign, I guess you could call it, in the leftmost column, and I'm going to click this settings. And here, this will open up a little breakpoint settings window right in line in my code. It pushed all the other code down. Notice that it goes from line 16 here to line 17 way below it. And I'm going to add a condition. And whenever this expression, a conditional expression, is true, then we'll break at that point. So in our case, when I is in fact equal to 7, then we'll break on that breakpoint. Okay? You can see that when I hit enter on my keyboard, it's saved, and now I can close this. You can see that the little icon changed from just a red stop sign to having a white plus symbol inside of it. So now when we run the application, notice that I is 7 and that I is 7, our little window here, before we even stopped into our breakpoint. And now we can continue stepping line by line through our code and continue on, right? And we got our result, and we can continue on. Okay, great. So again, I could spend an entire hour just showing you other cool little features that will help you debug your applications, but understanding how to set a breakpoint, how to run your application to a breakpoint, how to step through line by line, and then how to resume, at least resume temporarily or continue by using the continue button. Those are the key concepts in debugging, all right, using the Visual Studio Debugger. Now, let's go ahead and turn off this breakpoint. From now on, what I want to do is just eliminate it. I can do that in one of two ways. To completely turn it off, I can just click on it, it'll go away. Or I can temporarily disable it by using this little icon that was next to the gear that we clicked earlier. And now you can see there's a little outline in the leftmost column and an outline around the line of code that had the breakpoint, but no longer are we actually going to break on that line. Okay, great. So let's do this. Underneath the for statement from before, but above the console.read line, I want to do what I promised you at the very outset, which was show you a foolproof way that you can get the syntax right for a for iteration statement, and truth be told, for just about anything else, by using a little secret code snippets. Okay, it's not that much of a secret, but you probably didn't know about it, did you? Okay. All right, so to do this, it's really easy. If you can remember, I need a for iteration statement. Just type in the word for. You'll see that it pops up in the IntelliSense. And if you look after the IntelliSense pops up a little message to the right there, code snippet for loop, note, tab twice to insert the for snippet. All right, let's do it. Tab, tab. Bam, and there we go. And notice that it went ahead and pretty much set it all up, although there are some parts that we're going to have to change, like, for example, the length. But I could also change, I don't have to use the value I for my iteration statement as my placeholder, as my counter, whatever you want to call it. I could call something like my value. And notice as I'm typing, and then I hit the tab key on my keyboard, it changed everywhere that was using the I variable label to my value. All right, very cool. Hitting tab also took us to the next spot in our code that we're going to need to replace, which was the length, or in other words, how many times should this for loop iterate? And I'm going to say we'll do it until my value is less than 12. Now, here again, we can use a number of different equality or inequality operators here. We don't have to use the less than. We could use the equal, or we could use the greater than, whatever makes sense for our application. But I'm going to keep it simple and leave it just like that. Once I'm done making changes, I can just hit the enter on my keyboard. There were some highlighted areas that were highlighted in gold color, kind of, that indicate that these are replacement areas. They go away, and now my mouse cursor is right between the opening and closing curly braces. And at this point, then I can continue to, create my application, right line, and then my value, like so, and then we can run our application, and we would get the following result. All right. Okay, so just to recap, it was a short lesson, but we learned a lot. Not only did we talk about for iteration statements and why you might want them, and we'll see them at use later, but we also talked about the debugging tools, just briefly, and how to step through our code, how to monitor the value of variables, how to use the break statement to break out of a iteration statement. We looked at code snippets and how to replace values in a code snippet in order to make it our own. All right, so we'll use some of these techniques that we learned here throughout the rest of the series. Very important video. And so let's continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to talk about arrays, and I'm going to start by making a case for why you need arrays in the first place. So often, you're going to need to work with several related variable values, but how do you work with multiple variables and kind of treat them all as if they're part of the same group? Well, let me show you how not to do it. You can see an example of that on screen. First of all, I've taken the liberty of creating a project called Understanding Arrays, so make sure you catch up with me. Create a new console window application, and you can kind of just follow along. You don't need to type this part in. It's wrong anyway. Okay, so you can see what I've done here. I need to keep track of 5 numbers, and I need these numbers to be related to each other. So without any better tools in my toolbox, I might just create something called number 1, number 2, number 3, number 4, and give them each a value. And now I want to find which variable holds the value of 16. I'd love to be able to loop through them like we learned about previously to find which of the values hold number 16, but I can't really do that. I'm forced to create an if, else if, else if, else if, else if, else if, else if kind of structure, as you can see here below, in order to ultimately find which variable has the value of 16 inside of it. So this is not the right way to go about working with multiple values that are somehow related and you want to treat them as a group. There's a better way, and that, as you might assume, would be with arrays. So let me comment all of this out. And, previously I talked about a variable as being a bucket in the computer's memory that will hold some value. But let's expand our thinking about this for just a moment and talk about an array. Think of an array as like a bucket, or maybe even better, a tackle box. Have you ever seen one of those? If you go fishing, there's a lot of little compartments inside of it, and each one of those little compartments can hold something, all right, usually a little worm or whatever the case might be. Well, what if we were to use that instead of a bucket? What if we were to put values in each of those little tray areas inside of the tackle box and store that up in memory? And then whenever we needed a value out of that tackle box, we just need to take it and look through and find the particular compartment with what we're looking for in order to work with it. That's kind of the idea of an array, at least if you want to overextend the bucket analogy, okay? So another way to think of an array is kind of a sequence of data, a collection of data, although I'm hesitant to use those specific terms because they have very specific meanings in .NET. So think of it in a very general sense. You have a collection of data you want to keep together. How do you do it? Well, one of the ways you can do that is with an array. So let's do this. And I'm going to go ahead and create my first array here. I want you to follow along. And notice that I'm using square brackets. I'm not using curly braces, all right, when I'm working here. So all right. So first of all, let's take a look at the declaration of our array called numbers. It is an array of integers. In other words, there are going to be multiple integers all collected under the same umbrella named numbers. And you can see that not only am I creating the declaration for this array, I'm also using an equal new int 5. Okay, some of this, like the equal and the new part, we're going to talk about what that really means a little bit later, but for now just accept it as how you go about creating an array. All right, and then notice next to that I have int, and then inside of that, the square brackets, I have the number 5. So that's how many elements that I want inside of my new array. I want a new array of integers that can hold five values, 5 integers inside of them. Next, what I do is I begin to access each element of the array and put a value inside of that element of the array. So here's the first element of the array, the second element of the array. Remember, we're 0 based. Here's the fourth element of the array and the fifth element of the array. 5 elements inside of the array, just like we defined here in line number 31. Now, what if we wanted to access the value inside of one of the elements of the array? Well, I would do something like this. Console.WriteLine, obviously. Now, what if I wanted to get to and print out the value that's in the second element of the array? Well, then I would use the correct index of the array to access that element. So here's numbers, and I want the second element, which means I'm going to use the index 1. So I'm going to index into that array to get to the correct element. So in this case, the second element is at index number 1. All right, and I can print that off the screen. And let me do a read line here, like so, and we can quickly run the application. And you can see that we are printing to screen the number 8, which in fact is the second element of our array. All right. Now the other thing that we can do is actually determine how many items are in the array by looking at the length property of the array itself. So console.WriteLine, and I'll just go numbers dot length. All right. And so let's see what that will output. In fact, let me go ahead and comment that out and run the application. So you can see that we're able to programmatically determine how many items are in the array by using the length property of the array. All right, there's 5 elements inside the array. Great. Now, what were to happen if we were to attempt to insert data into another item, a 6th element of the array? What do you suppose would happen here? Well, we'll try it, and we'll run the application, and you'll see that we get an exception. An index out of range exception was unhandled. In other words, we are outside of the boundary of the space that we defined inside of our array. We're trying to access compartments that were never created in the computer's memory inside of our little tackle box, okay? So in order to remedy this, we can either redefine our array at the time of declaration that we need actually 6 items, or we can go ahead and we can change at runtime the number of items in our array. It's a little bit of an advanced topic. I don't want to talk about how you would go about doing that, but it is possible to do it programmatically at runtime. All right, so let's move on from there, and let's talk about maybe a simpler approach to creating new arrays, and that is to not only declare the array, but then also initialize its values at the time of declaration. So let me comment out everything I have here. And we'll do this. Now, instead of giving it a specific size, we're going to let the compiler figure it out on its own, because we're just going to start typing in the values of the elements that should be stored inside of our array. Now, in this case, I can create it, or just put all the items in there I want to put in there, and I can trust that the new array that will be created in memory will be able to hold all, 6 items this time, right? Okay, let me comment that out. And we've been working specifically with integers, but what if we were to work with strings? How would we go about doing that? Well, same sort of idea here. In this case, we want to give it a number of literal strings. Like so, okay? And so let me move this over a little bit. You can see that we are able to create an array of strings. We don't have to declare up front how many elements we want in our new array. We'll let the compiler figure that out. It will create 4 items. Now, there's a number of different ways that we can loop through to access each of the items in our array. Let me show you 2 ways, and one of them is going to be what you're already familiar with, the for loop, right? So I'm going to go for tab tab, and so we'll start with an integer I equals 0, and now let's do this instead. Let's go names.length, right? And then inside of here we'll go, let's do this, console.writeLine, and we'll go names, and then what do you suppose we'll put in the middle here? We'll use the value I, right? So what we're going to do is start at 0 and continue iterating through until we reach the length of our array, and then we'll stop and jump out of our array. But until then, we'll do a console.readline here, and you can see that this will allow us to print out all 4 items inside of our array to the console window. Great. Now, there's a lot of management of this I here, but there's an easier way to go about this. Let me comment this out real quick. I'm going to show you a second style of iteration statement. So in this case, we'll just do this. We'll do for each, and I'll go ahead and use the code snippet. I'll just go tab tab. So for each string name in names, all right, and I've made up the term name as singular, and names is actually what we called our array, right? So now I'm going to hit enter on my keyboard twice, and I'll just do console.writeLine name, and let's go console.readLine. What this will do is it'll allow us to essentially loop through every single name in our array of names, and for each item it will copy the current element into this temporary variable called name of type string, and then we can use that to do whatever we want. In this case, we're just going to print it off the screen. See how much easier that is? But we can use either technique in order to iterate through our sequence of data. Very neat. Okay. All right, now let me show you one last thing you can do. It'll be pretty powerful stuff. And we can create arrays of different things, right? So what if we wanted to create an array? What if we wanted to take a string and reverse the string, okay? How would we go about taking, for example, the name Bob Tabor and reversing that to what? Robat Bob, I guess. How would I convert? How would I change that? Well, what we can do is take a string and convert it into an array of individual characters. Once we have an array of individual characters, we can then say, go ahead and reverse the order of those items so that the last becomes first and the first becomes last. All right. So let's do this. I'm going to create a string called Zig, and it's going to contain one of my favorite speakers quotes that I have kind of patterned my life after. You can get what you want out of life if you help enough other people get what they want. All right. Now that's a very, very long line of code. So what I would probably do is I would try to chop this up into multiple lines of code. And we said this before that you can do something like this in C#. All I'm doing is going to just break it in half and use this concatenation operator, right, to kind of marry the first string and the second string together. So that's all one line of code. So now that I have this, what I want to do is create an array of characters. So I'm going to use the char keyword, which is the data type char, meaning I want one character, but I'm going to create an array of characters called, we'll call it char array. All right. I'm going to take this Zig string and I'm going to call a helper method on it called toCharArray. So every data type has some helper methods that are built into it by the .NET framework. And what this will simply do is take a long string and we'll split it up into individual characters and put those into an array of characters. Now that we have our statement here in an array of individual characters, I can do something like this. I'll call array.reverse, and I'm going to pass in the character array. And then finally what I want to do is we'll do a for each, tab, for each char, and I'll just call this a Zig Ziglar char, in my char array, console.write, not write line, but just write, and the Zig char. All right, hopefully all this makes sense. Let's do a console.readLine. And this is just to show you some of the flexibility of working with arrays. Let's run the application. And now we were able to write that whole string backwards. All right. So that's pretty much it. There's a lot more that you can do with arrays. However, as we move through C#, you're going to find that your use of arrays will diminish over time, and you'll start using something a little bit more elegant. Think of it as an array on steroids, or maybe like super array, okay? It's going to be called a collection. There's a bunch of different types of collections, and we'll learn about those near the very end of this series of lessons. But at any rate, that's how you work with arrays. Remember that you have to declare an array by giving it, at the time of declaration, its size. Then you can access individual elements of array by using indexes into the array to access or to set the values in a given element of an array. We can loop through elements of an array using a for or a for each iteration statement, and we can even use some cool utility methods like array.reverse to swap all of the items in the array, or there's also ways to sort items and so on. Okay, so let's continue on in the next lesson. We're doing great. See you there.
That's all for this episode. I hope this tutorial was helpful. Is your mind ringing with questions, queries, or doubts? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions in our forums. We will be extremely happy to clear all your doubts. If you missed anything and want to rewatch it, you can download it from our website or can watch it online as well. You can also participate in our webinars as well as discussions with the subject experts. Moreover, you will get Microsoft certification on various courses through our website. You can also find us on Facebook by the name Millionlights. We are also there on Twitter. For more such interesting tutorials on coding, keep watching Microsoft RF Code, brought to you by Millionlights. Thank you.